for any habit that we have completed. Then I will add another property, which is going to be a flag, and I'm going to call it isArchived. And even though this may seem like another status of the habit, I didn't want to mix the two. I want the habit status enum to focus only on the completion status of a specific habit, and we will use the archive flag for data archiving purposes. Now, if we want our habit to become a sort of a goal, we can go ahead and assign an end date to the habit, which is some fixed date by which we are supposed to achieve our milestone. Now, our milestone is going to be optional, and I'm going to define another type to represent the milestone. So let's create a public sealed class called milestone, and inside of it we're just going to be tracking the targets that we have defined here. So I'm going to have a target property for the milestone, which is how many units of work we want to achieve. And we're going to have another property to track the current status of the milestone. So once we achieve the target milestone, meaning these two values are equal, then we have effectively completed our goal. Then let's add a couple of datetime properties. They will help me track when we've made changes to our entity. The first one I will call created at UTC, and this will help me track when I've created my entity. Then I'm going to add an updated at UTC, which is optional, hence why it's a nullable datetime type, and is going to help us track when we have modified our resource. And then I'm going to add one more datetime property, which is going to be last completed at UTC, and this will just help me track when I've last completed a specific habit that has a milestone attached. So we wrote a bunch of code to make our first entity, and I only did this to make it more interesting when we start working with this resource inside of our REST API. Now, the next thing we need to do is to connect this with our database context. So inside of the database folder, I will create a configurations folder, which is going to contain my strongly typed EF configuration classes. So let's call this the habit configuration, and I'll make this inherit from the iEntityType configuration interface, and I'll specify the habit entity. We have to implement the configure method, and inside of it I'm going to apply some basic configuration. For example, I want to say that the key of this entity is the ID property. Now, because this is a string property, it will also be smart to define a max length of, let's say, 500 characters, although you may want to give this more thought depending on which value you want to use for your primary key. In my example, this is just going to be a 1 or 2 character prefix with a version 7 UUID, so this is more than enough characters to contain the primary key. Then I'm going to copy this and set the max length for the name property, and let's say that this is at most 100 characters, and I also want to constrain the description, and 500 characters seems like more than enough. Then we have a couple of classes inside of the habit type, which are complex objects like the frequency, the target, the milestone, and how you can configure these with EF Core is using own types, and I can say that my habit owns one and then specify what is the specific own type. For example, I can say that we own one frequency. I can also say that we own a specific target, and if I want to configure something specific on the target type, I can pass in another delegate here, which will allow me to configure the target properties. For example, I can access the unit property to define a maximum length of 100 characters. There isn't anything special that you need to configure if you want these to be nullable. So I can just say that the habit owns a milestone, and the fact that I configured it as nullable will be enough to translate these properties as nullable in the database. So this is enough setup for the habit type. The remaining things EF Core can pick up by convention. Now, how do I actually apply this in my database context? One thing I can do is say model builder, apply configuration, and initialize a new instance of my configuration type, or I can use the dynamic approach and say apply configurations from assembly, where I need to specify which assembly to use. So I can say type of application database context, and assuming that my configurations are also in the same assembly, this is how I can automatically apply my EF Core configurations. And then one more thing I want to do is to define a database set property for the habit entity. Let's call this the habits, and I'll give it a getter and a setter. So we configured our database context, we set up our database, created our first entity, and I think we are ready to create our database migration. I'm going to open up the package manager console, and I'll start typing my command for creating my EF Core migration. I will say add migration, give it a name, let's call it add habits. Now optionally, you can set up your database context name. In our case, this will be the application database context. This will be required when we introduce another database context in the same solution, but for now we can omit this. However, I do want to specify a custom output folder as migrations/application, and this is because I want to scope my migrations for this database context in a specific folder right from the start. So let's hit enter. This is going to create our database migration, and we can observe what we have inside. You can see we are setting up the database schema, creating the one table that we have so far, which contains a bunch of columns inside, respecting the nullability of the specific types. For example, the milestone target and the milestone current value are both nullable types. So let me also add a comment here so we can avoid any static code analysis warnings. And now I can close this down and move my startup project to be Docker Compose. So now when I start my application and I open up Docker Desktop, you will see that my application is running, and so is my Postgres database. Now, the first time you run this, you may run into an exception where you can't connect to your Postgres database. If this happens, I just recommend starting the project again, and this should succeed. Another thing you could do is set a dependency for the DevHabit API service in the Docker Compose YAML file and explicitly say that it depends on the database context. You can see that we don't have any exceptions so far. Let's jump into the Aspire dashboard. Here's what we can see in the structured logs. Here's a log from EF Core applying the database migration. And then there's the log that the database migrations were applied successfully from our helper method, which we run when the project starts. If you connect to this database from something like pgadmin or dbeaver in my example, you can see that we have the DevHabit database created. This is running inside of our Docker container. Then we have our DevHabit schema, which is what we configured inside of our application. And in this schema, we have the EF migration history table, which contains one row inside, the one migration that we have created so far. And then we have the habits table with the properties from our object model properly converted into columns inside of our database. So we can confirm that our database setup is working as expected. And now let's jump back into Visual Studio. One more thing I recommend doing while we are still in this stage of setting up EF Core and our database is also enabling database telemetry. And this is surprisingly easy to do. If you look for MPG SQL, you will find the MPG SQL OpenTelemetry package. Go ahead and install it. And then in your program file, when you're setting up distributed tracing, you can just add a call to add MPG SQL. And this is going to wire up the auto instrumentation or tracing using the MPG SQL library, which is also what we are using in our EF Core provider. Now, another remark I want to make right from the start so that you know what to expect is the folder structure that I will be using inside of this course. I specifically want to use a more technical-oriented folder structure because I think it will be easier to use this folder structure while explaining the RESTful API concepts. Once we establish an initial folder structure that's based on technical concerns, it won't be too difficult to convert it into a more use case-oriented folder structure, as you would see in something like a vertical slices architecture or the clean architecture. This is something that I will cover in one of the bonus lessons at the end of this course. But for now, I just want to make it transparent what I'm doing from the start. This concludes our current lesson where we introduced our database, configured EF Core, and we created our first entity. In the next lesson, we will finally start building our RESTful API, starting with getting resources.